we're going to be doing things. Hopefully everyone understands things. If you have any questions, feel free to ask them in the chat. I will try and answer them. And yeah. So, this is a base plate with a spawn pad. Very bland. It does nothing. You can spawn in and walk around, but not much happens. There's literally nothing here. Let's say I want to make something, which I will be doing. In fact, I'll be making a snow peep launcher. Probably should have led with that, but yeah, I'm going to be making a button, you press it, and then it launches a snow peep in some direction. So first, we need a button to press. Perfect. There we go, there's our button. Currently it does nothing. But the goal of this lecture is to actually make it do something, so alright, so here we have our button. To make it do something, we need a script. And this is where the main thing of the thing is. This is where the main lesson of the lecture is going to be. In here, in the code editor, where you type things. Now, not everyone here knows how to code. And that's bad. So I'm going to teach you how to code. The first thing we need to know is what a keyword is. A keyword is one of these red words. It turns red, it's a keyword. Now these keywords mean things. I'll get to what each one means as we use it, and I'll also show some that we may not be using but are still quite useful. Now, when you're coding, you might want to have the things called variables. This is like a little box with some data in it. The box has a label that tells you what it has, and then it also has stuff inside the box. To make a label for this variable, you can type whatever you want. Like, I could name a variable hi. Or I could name it hi with a capital H. This is different from hi with a lowercase h. Now, if we just do this, there's nothing in the box. It's just nothing. So in order to actually have it be something, we put an equal sign. just one. Two equal signs is a different thing that we use for something else that I'll get to later. And we put one equal sign, and then we put what we want it to be on the other side. In this case, I'm going to make it a word. Someone suggest a word in the chat for me to make it. Alright, the audience has spoken. I'm going to make this what high is. So now, at any point, if we want to use this word anywhere, instead of having to type the whole thing, we can just type this. And we can make a second one that's different. This is different because the capitalization is different, meaning it is in fact a different word. The capitalization does matter. Now, someone else suggest a word that this one could be. Alright, I've seen a few people type stuff. This one is going to be chips. Now, that's the local keyword means that if I were to put this inside a function, I wouldn't be able to use it outside. Now, a basic function that is used when coding is the print function. A function is just a thing that does stuff. It could be a function that is already there, and it does stuff that has already been told to do stuff. Or you can make your own functions that do your own things. This function here is print. The way you call a function, or the way you make a function actually do stuff, which is known as calling it, is you type the name of the function and then press, and then you put what you want to be printed inside the parentheses. That's how most functions work. You give it its things or arguments inside the parentheses. So for the print function, I'm going to give it the variable high that we made earlier. Notice how I have to use capitalization to reference the one exactly that I want. If I used the other one, like I made the I capitalized and the H lowercase, then it would make the other one. But I'm going to do this for now, and then I'm going to run it. And here we have fire in the hole. And then if we click on this, we can see it leads back here. Now, if I want to have the other one also print, I can make another print function, like this, or I can add a comma here. So now we have this, which means if I run it, we look in the output window, we get this first, and then after we get this, which is this here, we get the second one, which is just the second word. Now, that's the local keyword. If you want to make your own function, like we have print, and then there's also some other ones like warn and error, which are like print, but they make a different color. You can make your own functions that do stuff like this. So you type the keyword function. Then you put what you want the function to be called. And don't forget the parentheses. And then you close off your function with the end keyword at the end of it. And so this function is just everything that's in here, which is currently nothing. So let's make it do something. Also, this function isn't going to be used anywhere else, it's just going to be used in this script, so I'm going to put the keyword local in front of it. Now, to make a part, you might say, oh, just press the part button up here and it makes a part. Boom. Part made. But we want to do this in a script, and the way we do that is by using a service. Yeah. You need to use a service. Services are basically things you can use in your game that already exist, that have stuff in them. Specifically, we're going to be now. The instance service has some functions we can use. We're going to use the new function. Also, for some reason, when you're using the functions of services, you use a dot instead of a colon for some reason. We'll get to that in a minute when we get to how to reference objects that you've made, or that already exist. Anyway, it's a function, these parentheses. And then, what do we want to make a new thing of? We want to make a part. Anyway, so we have here, it'll make a new part. It has some default things, like a default position, look, size, shape. You can set those here. Now the first thing I'm going to do is give this a variable so I can actually tell it to do stuff. So now I have a variable called part, which is this. It's a new part. The first thing I'm going to do is give it a color. Color of the part is a property it has. Parts have many properties. In fact, everything has properties. You can see all the properties on the side here. We have the color of it, whether it casts a shadow, the color again, the material, variant of the material, how reflective it is, how transparent it is, some other stuff, such as its name, how big it is, whether you can touch it or not, whether it's frozen in place, how fast it's going and in what direction, whether it has mass, and then some tags and attributes, which are stuff you can use for more advanced coding. What we're currently focused on is the color, so we're just gonna get the color of the part by using the dot operator. The dot operator just lets you access either the children of something, which are things in the Explorer that appear below it like this, or properties, which are here in the property menu. I want to get the color, so I'll do part.color. Now, it has a red underline because I'm not doing anything with it, but this is how you reference the color. Let's say I want to set this to something else. Alright, so now that we have a reference to the color, we can actually change it to something else. Anyway, as I was saying before answering some people's questions, now that we have the color, we can change it. Just like how up here we were changing what the variable had to this on the right, we use an equal sign to change the color to something else. Now to actually get a color, we need to use another service, kind of like how we used instance here. But instead of using instance, we use color3. It's called color3 because red, green, and blue, there's 3 different colors channels that you add together. In other words, there's just 3 colors, that's why there's a 3. And then we use dot, and then we have 4 options this time. We can use new like before, but in a different context. Or we can use from RGB, from hex, or from HSV. All these different options are new is you pick between 0 and 1 for colors. For RGB, you pick from 0 to 255 in red, green, and blue separately. From hex, you pick between 0 and 255 again, but in base 16 instead of base 10. And then from hue saturation value, you pick your hue, how saturated it is, and then how black and white it is. If you know how hue saturation value already works, you're fine. Most people know how red, green, blue works, so I'm going to use that here. And then we can click this, we get a little color thing, we can pick a color. Wow, so cool. I'm going to pick this red. And it just fills in the numbers for me. But this first number would be how much red, this is how much green, this is how much blue. And then you add them together, you get this shade of red. Alternatively, we can pick some other colors, like this funny blue. This is just a color picker. Everyone knows how to pick colors. You can just think of a color and stuff. Anyway, we have a color, so the part will have a color. Next, we want the part to be somewhere. Where do we want the part to spawn? Let's just have it spawn right there. So that whenever we spawn a part, it'll appear where this one is. Spawn where that is. I'm just going to use this as a marker to show where the thing will be. So whenever we click this button, it'll spawn a thing there and then launch it. We'll get there when we get there, though. Anyway, if we run this now, we will not find the part anywhere, because it'll actually just appear underground, like here if I press run. It is nowhere to be seen. That is because it isn't in the workspace yet. The part exists somewhere. It exists in the void of nothing. We need to actually make it exist here in the workspace if we want to do anything. This is where referencing things comes into play a bit more. As I said earlier, you can use the dot operator to reference things. Like here, I've got used the dot operator to get the color of the part. Then I've also used it in these other spots to get a function from the service. But you can also use the dot operator to get to specific objects. Like let's say I make some parts. Let's say I make some parts. Let's say I want to get this part here, this block. I've named it block. This will be important later. Anyway, now that I've named it block, I can reference it here. In order to actually get the part, I would need to either reference the game itself, and then the workspace, and then from there I can find it in here, and then just follow the path I took to get there, so in model. Then model again, because it's inside a model in model. And then there it is. It's right there. I found it. That's one way of doing it. A second way I could get that part is by using square brackets instead. And square brackets are more versatile than the dot operator because let's say I have this other thing named 2. You might think, what does that have to do with anything? Why is naming it 2 so hard to reference? And the reason is this. I'm going to try and find it. Also, the workspace has a global variable that you can use to reference it, so you don't have to go game.workspace, you can just go workspace. But here I have the workspace, and then I have this model. And so I'm here, there, and now I just do 2. But this is wrong. This will not get this. It doesn't reference it. Look, it's turned orange. That means it's a number. It isn't dark blue like the rest of these. Because the 0.2, that's a number. It's 0.2. It's a number. It doesn't work. You can't get this thing. If the name begins with a number, you can't access it through the dot operator. And so instead, we have to use square brackets. And then we put a string that is the name of the part, like this. Notice there's no dot, it just goes square bracket, and then 2, or just whatever the name of the thing is, in quotes, so that it's a word and not a number. This is the correct way to reference something that begins with a number, has spaces in its name, or begins with an underscore. Because, like before, if I wanted to access, say, this other part here, I'm going to name it big wall with a space. There's a space in there. So let's say I want to reference big wall. This is another example of the square bracket operator. Now, I'm once again going to try reference it. So I have a workspace, and then it's just in the workspace, so I can just do big wall. But I can't do workspace.bigwall. Look, if I scroll down here, I can't find it. If I scroll down this list, there's no big wall to be seen. Well, there is, but when I click on it, it autofills it with square brackets. This is because there's a space in the name. And spaces are used to separate words, which means you can't have them be part of a name. Notice how if I just remove these, replace a dot, it doesn't get the whole thing because there's a space which separates big from wall. And also, you don't only have to use the square brackets for stuff like this. But you do have to make sure that it is it's a string or word that matches the name of the thing you're trying to get. So like back here, I could replace this dot with square brackets. but I would need to add quotes. And that would work. It's red underlined, but that's because I'm not doing anything. Now, I've seen I've shown the dot operator, the square brackets. There is one more way you can reference objects, and that's by using a specific function on a thing. So let's say I have the workspace again. Or actually no, I'm going to use the players object, this here. There's nothing in there though, so I'm going to play. Alright, so here's the players object. You can see it's not in the workspace, it's at the same level as it. But here's me. Like this is, that's me. It's me in the tab list. If I delete this, I get disconnected. Anyway, now that we know what that is, I'm gonna show you how to reference it, because it's not in the workspace, so we can't do workspace.thing. Well, we could, but if we did workspace.parent, but we don't need to do that. We can just use game.players. But I said there's another way to find things. And that's using the getService function. And then we type in the name of the service we want to get, in this case players. And then we can continue using the dot operator from there if we want. And then we could do some other stuff with it. It didn't work because this ran before I joined, and so it got to the end and that stopped. Anyway, another thing you can do is you can run code while the game is running using the console. You can either press F9 or do /console in chat. Then if I switch to server, I have a command line where I can do things. But if you're in Studio, you also have this thing called the command bar, which is exactly the same. It's just that it's not in here. It doesn't get in the way. But I can run code from here. The command bar is a lot like a script, but you only have one line unless you copy and paste a code from somewhere else, then you'd have multiple lines. So like I could do that, I could copy that and paste it in here. And now it's just there. I can run stuff in the command line. So that was the third way of referencing things. Note that getService only works if you're using the game variable, or if you're using it on the game variable. So like you can't do workspace.getService, you have to do game.getService. Now, if you are in the workspace, you can use if you are in the workspace, you can use stuff like find first child and then put the name, which is exactly the same as using the dot operator, except that it's kind of like it's actually more like using square brackets. But yeah, find first child, you put stuff in here, and then you can put the name of stuff. And then you can see we have everything that is up here. Anyway, answering some more questions. If you use the find first child function, it's kind of like using square brackets. You put the name of the thing in here, and then it finds that thing. And then you can use find first child again from there. You can just string the functions together, or you can mix it up. You can use the dot operator for one, then square bracket thing, find first child, another dot operator, more square brackets, and yeah. But the reason you might want to use one over the other is because you don't have to directly put a string in here. You could have a variable in here that could change to something else, and that would mean it references something else. But you can't do that with the dot operator. You can do it with the square bracket one, though. Alright, so I'm going to write this, but slightly differently, but it still works the same way. These two lines of code will do the exact same thing. They will go to the game, then they'll go to players, which is this thing here, and then they'll find a child of that called this, and then they'll run the kick function on it with an argument, the funny. Now the kick function just kicks a player from the game and then gives them this message, if you put it. But basically, get service is a way of referencing this, that, and all of those. Get service can be used to reference all these things that I've highlighted in blue. And only those things, and also a few more that you can't see. Such as VR service, which is quite interesting. As the name suggests, it's the service for the game that deals with everything to do with virtual reality. So this is a service you can use. There are many other services you can't see. In order to actually use this, you need to give it a variable. So I'm just going to call it VR service. And so now anytime I want to use this VR service, I can just use this variable I made. So like, let's say I wanted to do let's say I wanted to check if the person that joined is currently in VR. The service actually doesn't work in a script. You have to use it in a local script because there's the client and the server, and the client can do some stuff, the server can do some stuff. I'll explain what it is in a moment, but we're currently looking at other things. I'll get back to it. Alright, so feel free to ask some questions. I'll be answering them now. Alright, there we go. I'm gonna continue a bit now. Alright, so one more thing. There is this, I probably should have began with this, but there are a few different things you can use when coding. These are numbers, strings, which are just words. Maybe you put them in single or double quotes. Or you put them in 2 square brackets. Or you can put them in 2 square brackets, but the square brackets have some number of equal signs between them, and then they'll only be closed by another pair of square brackets with the same number of equal signs between them. So if I have square bracket, then 4 equal signs, and then another opening square bracket, everything inside will be the string. So these spaces, this new line, that is in the string. If I were to print this, there would be a new line in the string. And this will only be closed by another closing square bracket that has 4 equal signs in it. So this has 4, it can only be closed by another one with 4. If it had no equal signs, it could only be closed by another one with no equal signs. If it had, if I put another closing one in here, but I only put 3 equal signs, this doesn't actually close it. It only gets closed down here. I'm actually going to give these all their own variables. I'm going to name them string 1 through 4. Someone's asking about how error messages work. How do you know what's going wrong? So I'm just going to leave this as it is with these red squiggly lines and just run the thing, see what happens. So here we have an error message. It has the little X to show that it's an error. That's the time that it was made, and then it has some dashes. Where it came from, this is important. So where did this error message come from? It came from workspace.part.script on the 22nd line. So we have workspace.part. I think it's this one because these other two have nothing in them. .script on line 22. This is where the error is coming from. For anyone wondering why I'm not doing anything, it's because I'm answering people's questions in the chat. But to continue on from what I was doing, we can read this error message. It tells me where it happened, and it tells me what it was trying to do, and then what it got. So here it says incomplete statement. That just means I started something, but I didn't finish it. And that's exactly what I did. I have workspace.model 2. I have a part, but I'm not doing anything. But what it wanted to do was do something. So it said expected assignment or function call, which means it was expecting me to have an equal sign with something or to call a function. And then, if you do get an error, it stops there. Everything below does not get run. And yeah. And one more thing, I should probably explain what client and server are, because I mentioned them earlier, said I'd get to them later. But it's quite important. Alright, so, you may notice up here, it's kind of look like a game window and a pile of servers, and it says current client below it. If I click this button, it switches to server, and you may notice I'm no longer controlling my character. In basic terms, the server it's the server, it's what runs everything. And then the client is the player that's connected to the server. So like the server has the world and all the parts in the world, and the client connects to the server to play in the server. So yeah, the server is basically, it has the map and everything. It has all this stuff. And then the client connects to the server and gets information about this stuff. And then it also gives the server your player. And then you can move around, you can interact with stuff, and you can do stuff, and then the server has to keep track of you. It has its own thing. And so in a game, if you lose internet, you may have noticed everyone else freezes. This is because the server can no longer communicate with your client, and so everyone's frozen in place because they're not getting updated. And if I do something on the client without telling the server, I can do stuff like, look here, if I make a part, and if I just have this like be a staircase or something, if we go back to the server, there's nothing here. The server doesn't know that that thing exists because my client hasn't told it it exists. And if I woke up here, what do you think will happen when I go back and look at the server? Put your guesses in the chat. what do you think will happen when I go and look at this on the server? The server doesn't know this part exists, and I just walked on top of it. So far, one person has made a guess, but I would like more people to try and think what might happen. I'll give you a hint. If you've seen exploiters use anti-void, it's quite similar to that. Alright, I'm seeing a couple more guesses. Alright, I'm going to reveal the answer. What happened? What does the server see? What will happen when I go back and look at the server? The answer is... I'm floating. Congratulations. Congratulations to the one guy that guessed it right as I was revealing the answer. Now, there is another thing I can do to sort of show this live-ish, like what other people would see. Like if I go, if I do this, if I go to the test tab and I start a local server with a couple of people. Actually, just with one player, I'll actually have both the server and the client visible at the same time. Look, it's me. Right, so you can see I can move around, and then we see it on the server. If I make a part here on the client, but on the client it makes perfect sense. I'm just walking on a part. But I'm floating here. What I can also do is do the opposite of adding things, which is removing things, or just changing them. So I can just move this, and now I can walk through here. Client has some control as well. Things that are nearby, the client does the physics for, depending on how good your device is, what your graphics settings are set to, and such, things like that. So if I, on the server here, make some parts, and my character is way over here, the server will do the calculation for the parts falling over. But if I have the client nearby, the client might take control of some of those parts and do the heavy lifting for the server. Now, we can't see who owns these parts at the moment, but we can make it so we can see them. These outlines around the squares show who has network ownership over the part. I have green, and these other parts also have green, which means I have network ownership over them. What this means is whenever stuff needs to happen, like other players touch them, other players push them over, I push them over, they happen to fall over on their own, I have to do all the physics simulations for them. And you could incorrectly do them. Like you could have a hack client change the way they fall, you could have them teleport around. Like look, if I move these on the client and I have network ownership over them, the server sees them move. However, not every part is owned by a player. For example, you may notice this spawn pad doesn't have a green outline around it, which means I don't have network ownership over that, which means the server does all the calculations and stuff for it. Means if I move it around, see the changes because it's not expecting any. It knows that it has ownership over it, so it doesn't think they should change, and so it isn't looking out for them. But it is looking out for these other parts to change because it's expecting them to. Names for this. Now if I move this, server sees it move. This is called the client. This means that the client replicates changes that it makes to the server. That's the word, they replicate. To make changes to it, and then they replicate to the server. Because if the server has network ownership over them, it's not going to be looking for changes from someone else, because it's keeping track of them. You can force a part to be owned by some other player by just telling it to. That's a thing you can do with code. You can tell something, hey, you should have this player or the server have network ownership over you. Now, this cylinder doesn't really look like a cylinder because you can't really zoom out. I'll change that. Alright, so as you can see, there's a green circle. Green circle. If there are parts outside this circle, the server or a different player whose circle is inside will own it instead. So like if I go all the way over here, all the way to the corner, and I make a part. They're still green. Why are they still green? They're not supposed to be green. Why are you green? Alright, there we go. Now there's another circle, which is blue, because it's not me, it's a different player, so it's blue. Also see that you can see that some of these are red, which means that they're kind of like transitioning between the server and client. But these ones back here are white, because the server owns them, which means that if I move those parts, they won't go anywhere. If a part is anchored, like the spawn plate is, or the base plate, it is always owned by the server, because it's anchored, it's not going to be moving anywhere, so why would you need to have the players do physics on it? It's not going to be moving. And so you just have the server deal with all the not calculations, because there are none. But if something is moving, or it's not anchored, then it does have the option of its network ownership being transferred. it seems that it's showing red, green, and yellow. Green is just, in this one, green are parts that I own, white is owned by the server, and then red is not owned by me, it could be any other player. And then in this other one, instead of green, it's yellow. So if I were to move some of those red parts, they wouldn't move anywhere. Can't see them moving. But if I move this other one, you can see it move. Until it gets too close to player 2, and then they get network ownership over it, which means that I'm not actually moving it anymore. And then you can see here on the server, when I move the parts that I have ownership of, you can see them moving. Alright, so I think we all know what the client, or what the server and a client are. This is the server. It has the world, and it also has the ultimate decision making. Like, look, I can just move anyone's parts, and they always they update for everyone. And then on the clients, they have much less control over the stuff. So that's the client and server. If you do stuff on the server, it replicates to the clients, but if you do stuff on the clients, it may not replicate back to the server. Anyway, back to coding. We were trying to make a part spawn, but we need it to actually have a position. Then I got sidetracked. So, in order to just get rid of all this stuff down here, I'm going to add a comment by doing 2 dashes, and then to make it multiple lines, I'm going to do the double brackets thing I had earlier. You may notice though it gets stopped because there's 2 brackets here, so it closes. So I'm going to add an equal sign, so that you have to have the closing one also have an equal sign in it. There we go. Now, to set the position of something, everything that is a part has a position and a rotation together. This is they do have a position and they do have a rotation separately, but together this rotation and position make up a thing called a coordinate frame, or a C-frame for short. So if I want to move this part, I have to change its C-frame, not its position. So I would do part dot C-frame equals some other thing. Note that you can also access the position or the rotation separately, but if you do access the position or rotation separately when on a C-frame, you can only read them, you can't write to them. So to change the position of something, you can't do C-frame.position, you have to change the whole C-frame. So, to move this somewhere, I'm going to make a new C-frame, kind of like how I did here with color 3 and here with instance. I'm going to do C-frame dot new, and then I'm going to add my parentheses, and I could just leave this blank and it would give me a blank C-frame with nothing in it. as in it'd be at the origin 0, 0 with no rotation, or I can give it a vector 3, which is the fancy word for position with no rotation. Vector 3 is just point in space. This thing's position is those numbers. So like this would be a vector 3. And it's gone. But yeah, that's a vector 3. The orientation does not exist as its own thing, I believe. It has to come with a position. So this thing doesn't have rotation, we're not going to care about it. I'm actually not going to make a new C-frame, I'm just going to copy that part's position. So we're going to have the part spawn where this block is, hence why I've anchored it. Made it kind of transparent, because it's like just marking a position. And the way I'm going to get its position is I'm just going to reference its position. I'm going to get this. Or rather, I'm going to get both of them, the position and the rotation together. Even though it has no rotation, but that doesn't really matter. So, who remembers how to reference things from earlier? Anybody? Alright, someone said me, go ahead, can you remember how to reference objects? I'll give you a hint if you did forget, it's also down here. Yeah, that is correct. We do use dots. We can, or dots are one of the options, so I'm going to do workspace dot part position. There's a dot. But I don't need the part itself, I just need its position, I just need this C-frame. How might I get that? Does anyone remember from earlier? Anybody want to have a guess? The question is, how we have the part, but we want the position of the part, or the C-frame. How do we get that? Oh, someone said it. Yep, that is correct. We do use dot C-frame. But there's a typo in your answer. Can you spot the mistake? This is what you answered with, but there's one thing missing. And yes, someone else answered. The F needs to be a capital F. Like that. So you were close, but yeah, very close. Anyway, now we have the C-frame. We're done. It'll just copy these numbers, or this list of numbers, and then put them into this part. And then one more thing we need to do is actually put the part in the workspace, because currently it's just out in the void of nothing. So we're going to set where it is, or its parent, because object-based programming languages have a hierarchy of stuff like this. This model here, its parent is this other model, its siblings are 2 and part, and its children are block, part, and part. If we change its parent, it just moves elsewhere and brings its children with it. And the way we can reference stuff, we can go down the chain through names, or we can go up by using the parent sort of word, sort of keyword. So we would do part dot. This just references the thing above it, so nothing in this case, because it's just out in the void. It isn't in the workspace, it was created. And then we just set this to the workspace. So if we set its parent to the workspace, that means it'll go in among these things somewhere. So let's test it. There should be kind of blue part where underneath that block. There isn't. Ah, I know why. This is a function. It does stuff when we tell it to. We've told it what to do, but we haven't told it to actually do the stuff yet. One thing I forgot. When you make a function, which is what this is, you have to call it afterwards or tell it to actually do the stuff. The way you call a function is you get its name. Just do that. Type its name with the parentheses afterwards, because it's a function, not a variable. A variable would just be a plain word that looks gray, but it's turned yellow, so I know it's going to work. And also these things erroring are kind of getting annoying, so I'm just going to comment them out. Alright, there we go. Those two things won't be bugging us anymore. I've turned them into comments. Comments are just notes to yourself. The programming thing doesn't look at the comments, it just ignores them. But you can see them, so like you could write notes to yourself, or rather you could write comments to yourself, like this part does whatever. This part doesn't actually do nothing, it deletes this. It doesn't actually work, because if I want to actually move it, I'd have to set the parent. Alright, now that that works, we can play. And there should be a kind of blue block underneath that transparent one. And there we go, look, it's a blue block. It's blue because we told it to be blue here. It's at this position because we told it to be at this position. And it fell because it wasn't anchored. I didn't tell it to be anchored, so it just fell. You may notice it has a size, I can see it. And it also has a shape, it's a cube, it's not a cylinder or a sphere. That's because it had some default things, and you may also notice it has studs on top. If we want to get rid of those studs, we can set the material as well. And if we want to make it bigger, like that big wall, we can set the size. So, I'm not going to do that. We can. And also another thing. While I'm here, I'm going to copy this. Now, earlier I said I would make a snow peep launcher. So far, we've just made a part spawner, not a snow peep launcher. It just spawns regular parts and then they fall. They aren't snow peeps and they don't get launched. Now, to make them into snow peeps, I'm going to use this. So here's a block. I select it. It's still the same shape it was before I added this. So it's still that rectangle. You can see by the blue outline. If I were to interact with it, it would be this shape. It just looks like a snow peep. It isn't actually shaped like one. Also, I can stretch it. And then if I play this, I can stand on top of the... I can stand on top of it because it's just a block. Notice how I interact with this blue outline and not the actual model that's there. Then you can see here on the bit that sticks out, I still interact with the model, not the bit in the middle. And if I remove the special mesh, we can see it was just a regular part all along. But now if I add a new one, the size is reset, or the size of the mesh is reset, but it's still a really big block. If I wanted this to be a lot more accurate, I would probably put it on a sphere. So that, actually like rolls around. And then also my camera gets blocked by it, even though it seems like there's nothing there. Now if I want to use this special mesh, I need to have it somewhere. Put it there for now. So that it just looks like that becomes solid and then launch somewhere. Now in order to make the parts actually look like Snow Peep, I need to give them this special mesh. In order to give them that, I'm going to copy it and then put it onto the part. But first, I need to turn the part into a sphere and make it the right size. We do that the same way we did the color, except that instead of color, we're changing the size and the look. No, size and the shape, yeah. So, first, the size. Earlier I said you can just have there are vector 3s, which it's vector 3 because it's a 3D vector, because you have up and down, left and right, and back and forward. There's also vector 2 when you're dealing with UIs, because your screen is flat. But this is not your screen, it's 3D space. So, vector 3. Part.size, because we're changing the size of it. So part.size equals vector3.new, and then we just put the x, y, and z coordinates in here. In this case, 1, 1, and 1. So it's going to be 1 stud tall, 1 stud wide, and 1 stud long. Let's test this. Sure enough, it's 1 stud tall, 1 stud long, and 1 stud wide. We can tell from the grid lines on the floor, because the grid lines are 1 stud each, and they make big checkered pattern of 4 studs. But you can see it's 1 stud big. Someone asked how to make it continuously get bigger. I'm gonna do that. So the way you do that is you'd have a thing that loops forever. Oh yeah, I forgot to say this earlier when introducing keywords. There's this, to make loops, there's two ways. You can use the for keyword, or you can use the while keyword. I'm going to use the while keyword in this example, and also to see where I'm coding, just look here near the top. So while loop, it keeps looping while some certain condition is true. So like, while I'm touching this block, make the block green, and then when I stop touching it, I could make it red or something. In order to make this always active, I'm going to do while true, which just means that while yes, do this. And then I tell it what it's going to be doing. So while true, do this part here. So while true, do workspace.blue part, which is this thing. I want to make it constantly get bigger, so I'm going to get its size. I'm going to set its size to what it currently is, plus some number. Let's just say 1. Or no, let's say 0.1. Then, I put the end keyword. But, I do not press enter yet, because it's going to go, while true, do blah blah blah. Oh, I get this size, make it bigger, boop. And, oh, it's the next game tick. Well, what do I gotta do? I gotta make this bigger. And it just keeps making this bigger. It goes along, making it bigger and bigger and bigger. And that's all it does. It does nothing else. It doesn't check for what clients are doing, doesn't update the physics of objects. Literally nothing. If I were to press enter there, my Roblox studio would hang, and it would never stop. Just wouldn't. Don't do that. Always include a wait somewhere in your while true loops, if they aren't going to just end. I'm going to have it wait 0.1 seconds, because for the wait function you put the amount of seconds you want it to wait. And now I'm going to press enter. It didn't work. This is because you don't just add a number, you have to add another vector to it. So I need to do vector3.new, point 1, point 1, point 1. There we go, now it's growing. Constantly. Also, it didn't snap to the floor because I wasn't near it. You may notice on the server it just looks like the part is floating, because remember what I said earlier about how the client can do stuff and the server also does stuff? The server might not always know what the client is doing. So the client is telling the server that the part should be up here, because that's where its center is. But it doesn't tell the server that it should get bigger as well, so it just kind of looks like this part is floating. If I were to walk away and lose network ownership, it would fall back to the floor. So if I do this, it's fallen back to the floor, it's on the ground now. But now that I'm nearby again, it's back up in the air. But if I do it here, it tells the client, hey, it should start being this size, and then it starts doing that. And now the server knows that it's growing. It's just growing. It won't stop because I haven't told it to. Okay, that's the size, but like I said earlier, we want it to be a sphere, not a block. The way we do that is, I'll do that in a moment. The way we do that is we access the shape property of the part. So part.shape, and then we set it to being a sphere. Now, in order to actually tell it to be a sphere, we have to use a list of things. In Roblox, the Roblox Studio, there's this big list of a lot of things called enums, which is basically just a big list of everything. It's a big lookup table, if you know what those are. If I want to be, if I were to tell the color to be through a brick color, so like if I were to say part.brick color equals bright yellow, that bright yellow is meaningless on its own. And so the game looks through this list of enums in the color section until it finds one labeled bright yellow, and then it uses that color. That's how it works. And so I'm going to do the same thing here, but instead of color, I'm going to look through shape. So enum dot part shape, part type, and then I want the sphere one. Might be ball, I'm not sure. I think a better list would be the list of materials. 'Cause like, basalt, all on its own, has no meaning. It's just a word. You look in the enums list for basalt, and then it gives you the texture to use, or it points you to where the texture is, so that you know which one to use. And also like sound for walking on it, that could be configured by the player. But it's a list of enums that the game uses. Anyway, what I'm looking for here is ball. Not sphere, ball, because it's for the it's designed so that children can use it, so it uses ball, not sphere, because not everyone knows what a sphere is. So this will, from top to bottom, assign the variable capital H lowercase I with the string fire in the hole. It'll assign the string lowercase h capital I with the word chips. It'll print those out. It'll print one of them out again. Then it will make a function that makes a part, colors it, puts it somewhere, makes it a certain size, makes it a certain shape, and then finally puts it into the workspace so that you can see it. And then it does those things. That's what this line is for. And then in here's a bunch of stuff that we don't want to worry about, so I've just commented it so that it doesn't do anything. Now, we want this to run every time you click this button I made at the beginning, but it just runs once when you start the game. So, I'm going to use an event. I'm going to make it so that when you click this, it goes. So, the way we actually make it so you can click this is we give it a click detector. Wow, amazing name, I know. So, it now has a click detector. This means that you can put your mouse on it, and then you can click on it, and the click detector detects it. It also makes your mouse have the pointy finger icon. But now we can click it, but nothing happens when you click it because we haven't told it to do anything when it's clicked. First thing we need to do is actually get a reference to this click detector. So what I'm going to do here is use the local keyword because we're not going to be using this anywhere else. Then I just give it a name that I'm going to remember, click detector, and also that describes it very well. Then I use the equals to tell it that we're going to be setting this to something. And now I'm actually going to reference the thing I want to use. So I'm going to do script.parent.clickDetector. Now what this does is we start at a thing called script, which is it's this. It is this thing here. More specifically, it's this. Then it looks for the parent of this thing. That's what the parent thing is for. So it goes up one, finds this part, and then it looks for a child of this part called click detector. It finds this. Yippee, we got it. So now we have the click detector. We need to actually tell it to do all this stuff whenever they actually click it. And that's where events come into play. I've not mentioned them at all yet. An event is basically something that happens. So as in, when you, like if you click a button, it fires an event. That's what it's called. The event fires. Kind of like how you would fire a gun. So when you click the button, it goes, it fires the event, and then anything that's listening out for the event to fire will activate. So I'm going to make it so that this script listens out for when the event fires. Kind of like how someone might listen out for, or how runners in a race would listen out for the starting pistol to go off, and then they'd run. But the people across the road doing their own thing, they're not listening out for the starter gun. They won't do anything when it goes off, because they're just not listening for it. So we're going to do click detector, referencing the object, dot mouse click, as the name suggests, this is what happens when you click on it. You may also notice this right mouse click. That's when you click on it with your right mouse button, as the name suggests. But once they do click, we're going to tell it to run this function, and you do that with connect and then the name of the function. And so there we go, that's it. We now have it so that when the click detector gets clicked, it runs this function, which is just all this. So if we click that thing, it'll do all this stuff. Let's see it in action, assuming I did everything correctly. So let's see, when I click this button, it should spawn a blue ball over there. It does. Yippee. Now you may notice I've got a very precariously placed stack of balls because they're perfectly balanced on each other. There's nothing disturbing them, so they're not going to fall. And they go everywhere. However, there is a problem with this. What if someone decides to keep pressing the button and spawning balls? Or just objects, anywhere. You keep spawning objects, loads of objects appear, and your game lags. You might want to get rid of them. And so to get rid of them, I'll explain that after I answer a couple of questions. Alright, now, someone asked how you make loops and stuff in your code. The way you do that is you just use let's say I wanted to right, let's say I wanted to have a message appear in the console every 3.25 seconds. One way I can do that is I could have a message appear for everything in a list. Notice I said for everything in a list. That's how you use the for keyword. So, something I was going to explain earlier, but never got around to, are tables. This is a table. It has curly brackets. You can put stuff in there. Note that stuff may include another table. Alright, so Fun fact, you can type emojis in scripts. And I'm also going to include that hi from earlier. Now, this is a table. Each thing has an index, which is just where it is in the table. Unlike most programming languages, Lua starts counting from 1 and not 0, which means that this is the first item in the list, this is the second item in the list, and this is the third item. You might be wondering, but that's how we normally label stuff. How is that different? What's the deal with 1-based index and 0-based index? Well, it's because most programming languages start labeling from 0 instead. So this would actually be the 0th item in the list, this would be the first, this would be the second. That's what other programming languages do. But not Lua. So, now that we know that, or now I've said that, I'm going to continue with the tables. This is just a table with indexes, but you can also have a dictionary, which is a list of values that have a value, and then a name for it, and then you reference them via that name, rather than their index, because they aren't sorted in any order. It's like a bag of stuff. If you imagine, a dictionary is like a bag of stuff that you can put multiple things into, and then if you want to get something out, you have to get the name of the thing right, and then you get the data for that thing. But a list is organized, and each thing has a position in the list. So like, this is the first spot, that's the second, third, yeah. Now, to make a for loop, you would do for the iterator, and then the thing in your list, do something. What this does is it goes over each thing in your list and does whatever to each one. So, in this case, I'm going to make it so that for each thing in this list, or for each thing in this table, I am going to make it so that it does this. It prints out the thing. So it just prints out what it is. I'm actually going to make it say going to make it do this. So for the current iteration of the thing, and then the actual thing in the list, the current thing in the list, it will do this. So this will print. I'm just going to run it and then explain why it does what it does. Alright, so we can see here item number 1 is colon 1. Item number 2 is colon the can of corn. Item number 3 is colon fire in the hole. And then we can see the time each thing had: 52 seconds, 56 seconds, 59 seconds, 33 minutes past 17 o'clock. That's when they happened, and then this is what the actual thing printed. It also says it down here in the output, but down here in the output I can actually click on it and it will take me to what made the thing. Now, you may notice that I wrote print item number I is thing, but it changed I to a number based on what iteration it was. That's why we use I. It stands for iteration. And then it replaced thing with the thing in the list, because that's what this word was. If I had written object instead of thing here, I would have written object here as well, but it would have outputted the same thing. And you may also notice that item number 3 is the thing we made earlier. It took the variable and replaced it with what it actually meant. That's how you use a for loop. But there's another kind of loop called a while loop. I showed you one earlier when I made the part grow forever. Now, the second kind of loop, like I just said a moment ago, is a while loop. So the way you would say it in plain English is, while this thing is happening, do this other thing. Now, the way it actually works is you do while, and then you type whatever you want in here, but whatever you type in here has to come out to true if you were to evaluate what it means. So like, while 1 plus 1 equals 2, now you may notice this isn't going to change, so this is going to, whatever is down here is going to happen forever. And another thing you may notice is I've used 2 equal signs, not 1. The reason is because, if you remember back here, I already used 1 equal sign to mean assign this value to this thing. And so, we need to have a second one to make a new thing. So, while 1 plus 1 equals 2, that's a constant, it's not going to change anytime soon. It will do whatever's in here, like print hello world. And then I'm also going to make it wait which is very important. Because if I don't make it wait, Roblox won't have time to do other things, such as, you know, anything. So, I'm gonna put a better example here. While while game.workspace.bigwall do print hello world and then wait one. Now, will this one ever stop? Take a guess in the stage chat. Will the code executor come down here, get to this, and then will it just cycle endlessly back and forth between these? Or will it break free eventually and continue going down? And if so, and if it will break free, why? If it won't break free, also, why will it not? Come on, class, someone take a guess. Alright, one person has made an assumption. And now, let's see if they're correct. I can tell you now it will stop, but I want you to give a question. When will it stop, and why will it stop? For what reason? Well, I'll just tell you, the reason is because the condition is no longer met, that's when it stops. But why would the condition no longer be met? And why does it work in the first place? I'm gonna just show you now. So, here we have our script. It'll go through, do that. It'll get to this while loop. Now, you may notice this doesn't say true, and it's not like an expression that is true. It's not like 1 + 1 = 2. Now, the way you interpret this is if your condition is an object, in this case, this big wall, it checks to see if that object actually exists. So, let's follow it. game.workspace big wall. That does exist where we can find it, so it would come out to true. So while true, do, and then it would do this. Now, with that said, why may the condition become false? Any guesses? Alright, the question was, why might this equates to true because big wall exists. Why might the condition become false? Why may the condition break, no longer be met? That is correct. If the part is destroyed, then the condition will no longer be met because the part doesn't exist anymore. It'll go game. It'll go game.workspace.big wall, but it won't be able to find one. It won't be able to find a part called big wall, and so it'll be false. And so it won't run the stuff, it'll continue going. Now, if there are multiple parts named big wall, you'll have to get rid of all of them, because if it finds any of them, it'll continue, and so it'll just find one, but then if you destroy that one, it'll find a different one. But what's important is that it is still finding a thing. It's when it can't find one anymore that it stops. So I'm gonna put this over here for easy destruction. In order to actually destroy it, I'm gonna push it off the edge. But in order to push it off the edge, I need to push it. That may be a bit more difficult. It might be more easily set than that. Alright, so let's see this in action. So we can see it continuously writing that. I'm just going to stick this in the corner. And now I'm going to destroy the thing. And we can see it stopped. But it stopped because it errored, not because the condition is false. It still stopped though. But it didn't continue going, which is not what we wanted. So instead of using square brackets, I'm going to use the find child function. If I do this, it should work as I expected. Alright, let's see this again. And also to show the chat, you can to show the console, you can also use this command instead of F9. And there we go. It works without erroring. Because the part was destroyed because it fell into the void. Speaking of getting destroyed, we need to destroy these parts so they don't build up over time. Because right now, you can just click this forever and just accumulate 10 bajillion parts. That's not good, because your game will slow down, server may crash, memory leaks, bad, old bad, 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 bad. You don't want that to happen. Your computer will explode if it gets too bad. Now, earlier someone said, do we call destroy on each part after some number of time? The answer is yes, we can. You can use the destroy function after waiting some time. But, what if you go to call destroy on it, but it was already destroyed by something else? It's like the void. The script will still run, and thus the script it'll try and destroy something that doesn't exist, and then it will run into an error. And if there was any more code afterwards that was supposed to run, it was like very important, it now won't because the script stopped running because it errored. This is bad. How can we prevent this? Well, there's two ways we can prevent this. One is to use a different method that doesn't error, and the second is to catch the error and then just continue running code anyway, even though it errored. To do the latter, which is make the code keep running when it encounters an error, you need to get it in a protected call, which basically means if this errors, don't complain, just keep going and tell me what the error was. And we do not use find first child again. You can just make a script that each of these balls gets that it'll destroy itself after some time. But if it already gets destroyed by the void, that will run into an error. Anyway, if you would use protected call, it's called p call, p for protected. That would catch your error, and you'd continue running code afterwards. But there's a much easier way. But a consequence of this much easier way is that you can only have 500 of these parts at once. Otherwise, it'll start deleting them sooner than the time they have left. So, what are these magical ways? Now, we can't just stick a wait 10 bajillion seconds in here and then destroy it afterwards, because actually, yes, we can. But this has the problems I mentioned earlier, because like, then it may not get to later code, and your thing will break. Let's try this and see what happens. This is not the better way. This is bad. You shouldn't do this. I'm just showing you as an example of what not to do. Now, this works. It makes the parts and then destroys them after some time. But what if I do this? Whenever they go to do stuff, their script will run into an error. Because it tries to destroy something that doesn't exist. Also, I accidentally deleted my own character, but that doesn't really matter. Anyway, the point is, it isn't reliable. Instead, what you should do is use the debris service. Kind of like how we had VR service earlier. And then there's all these other services, like server storage, script service, related storage, material service, blah blah blah, all those stuff. Sound service. There's this service called debris. For those wondering why I'm currently doing nothing, I'm answering questions. Alright, so, I was gonna say it earlier, this magical method that we use, or can use to get rid of stuff after some amount of time, I said it earlier, is the debris service. I'll answer your questions about sound in a moment. For now, debris service is used to delete things after a set number of time. Anyway, debris. To get debris, you may remember earlier I got VR service. You do the same thing, only instead of VR service, I'm getting debris. And yes, the S is pronounced E. Don't ask me, ask the person who made the English language. Now, to actually make the part despawn, we use debris dot add item. No, not dot, colon, add item. And then we add the item that we are deleting, add the thing, which in this case is the part, and then we add how long it should last. Let's say 100 seconds. Or no, 5 minutes. And there we go. The parts will despawn after 5 minutes, but for the sake of example, I'm going to make them despawn after 5 seconds. So let's count. 0, 1, 2, 3, 4, 5. They despawn after 5 seconds, which is exactly what we were trying to do. I'm going to increase it to 5 minutes. Now, we still need to do two more things with all the sidetracking that we've done. We need to actually make these look like Snow Peep, and you know, make them launch in random directions. So that is the last thing we're going to do, and then I'm going to end the lecture. To make them launch in random directions, I'm going to show you with another example. Here is an object. So if I go here and look at its properties, there's one down here called assembly linear velocity. Now, let's break that down into its words. Assembly, that is, it's this. Linear, it's in a straight line, and velocity, that's how it's moving. So, anyone wanted to take a guess at what assembly linear velocity does if we add numbers? No? Nobody want to make a guess? Anyone gonna make a guess? So yeah, velocity does move stuff. And yeah, if we set, if we just change this to some numbers, assembly linear velocity, so like if we change this to 1, 10, 1, it starts moving. And you may notice here in the corner I have this block. These x, y, and z things point in the positive direction, so that's positive x, positive z, positive y. If I change this to 10, 25, 10, gets launched a bit more. And if I stop this, right now it's completely still. I'm going to put it back over here, and I'm going to give it some bigger numbers. $100 on the y-axis, it goes up. I think you can see where this is going. Now if I make this smaller, and give it the same boost, it seems to go a bit higher. Make it smaller again. It seems to be going the same height, but yeah. That is how we will make these things launch randomly. But how do we make them launch randomly? Keyword random. How do we get randomness? The answer is by using the math library. Yes, we use math.random. We can also, the math library has a bunch of other stuff like pi, trigonomic functions, sine, cosine, tan. There's also math.huge. it literally, it says infinity, but it's actually infinity minus 1. But anyway, if I do this, if I do math.random, then I give it a range of numbers, so let's do 0 and 1,000. Get a random number between 0 and 1,000. And then, because of how computers work, you can't get true randomness. So it's called pseudo-random, because like it's, if you have the same starting conditions, you will get the same result. But it's still kind of random. But if you have the same starting conditions, you get the same result. That's called being deterministic. You can determine the outcome given the starting position. True randomness would be, even if you had the same starting position, you get a different outcome. You don't got that here. So, you get a random number, but if you had the same starting position, as in, like if I set this seed to 2 and I do math.random, it's always going to give me 254. Because look, I did it again. I can do it again as well. You can see it gives me the same 4 numbers every single time. Look, we have 254, then 277, 980, 823, every single time. Because I set the seed to the same thing every time, and I did the same things between them every time. Anyway, you're not going to normally be able to set the seed during the game running, but you can manipulate it, and people have done that for stuff, but we're not going to do it here. Just going to not think about it too much. So, now you can set that number directly like I did, or you can use a function that does it for you. Now you do part : apply impulse, I think. Yeah, and then you give it a vector. So I'm gonna have it be random. So on each axis I'm gonna have it between negative 1,000 and positive 1,000. Except on the y-axis. It's going to be between 0 and 1,000, so that they only go up or sideways in the very rare cases. Now the way I'm going to do that is, so I'm going to have vector3.new, and then for each component, x, y, and z, I'm going to do math.random. And then it's going to be between negative 1,000 and 1,000. But for the y-axis, I'm going to have it between 0 and 1000 so that they only go up. Alright, so let's test this out. They are not getting launched. To fix this, I'm just going to move this so that they get added to the workspace and then they get hit by the force. There we go, let's try now. There we go, they're getting launched. I think I'll add a big box so that we can actually see where they end up. Alright, there we go. They're getting launched about. And then they'll also despawn after 5 minutes because I told them to do that. But there's still one more thing we need to fix. Those are not snow peeps, they're blue balls. So, I'm going to fix that. In order to actually make them look like a snow peep, I'm going to use the clone function. So first I'm going to actually get a reference to the snow peep thing. Right, there we go. So now I have this variable called peep mesh, which is just that. And that's what makes it look like that. So now all I need to do is clone it. So I take the mesh, I clone it, and then I set the parent to this part. And also I'll change those numbers to 100 instead of 1000 so that we can actually see them. So, now, here we go. No way, look guys, it's Snow Peeps. They come out of the part. So, one last thing I'm going to do is remove those parts, and then I'm going to add a box around the edge, so that, yeah, I'm going to add a box around the edge. I'm going to add a leaderboard stat to keep track of how many peeps you've launched. Isn't that amazing? Problem is I may not be able to detect who is clicking it. Maybe. But I'm going to add one last thing, which is a leaderboard statistic that shows how many peeps or I guess I'll just launch how many peeps have been launched while you're in the server. Maybe been by other people, maybe been you, but yeah. Snow peeps everywhere. Right. Don't need those. Move this button. Alright, there we go. So, one last thing I'm going to do before ending the lecture is adding a leaderboard statistic. Snow peeps seen. So, I'm just gonna... And also I'm gonna show you how to make it so that when a player joins, something happens. First thing you'll want is a script in server script service, because this is just a generic script that affects the game and not a specific thing in particular. So, first we need reference to the player's object, which is this thing. So I'm going to do game.getServicePlayers. Right, so now that we have that, I'm going to make it so that I'm going to make a function on player join, make a new thing. Watch this, I'm going to do magic. Actually, wait, hang on. When you're making functions, you can also add your own arguments to them by just putting the name of a variable in here, and then whenever you want to use that variable in the function, you just use it. Just like I want to, when a player joins, I want something to happen to them and not any of the other players, so I would use this variable to reference them. So I would have player, or actually no, I'd make a new folder. It seems that word is already being used for something because it's tinted light blue. I can't have my variable be named that. Name it player stats. I'm going to name the folder leader stats, and it's important that I name it exactly this with no uppercase letters, otherwise it won't work. And then I'm going to put this folder in the player that joined. So I've done that. Now I'm going to put a thing into this folder. It's going to be a number value. Alright, so there we go. Now I need to actually call this function whenever a player joins. And the way I do that is I get the players thing, and then I look for the player added event. Remember earlier when I had the click detector have the mouse click event do something? Well, I'm going to do the same thing here, but instead of clicking it with your mouse, you join the game. So, now, when I play, I have a stat called Snow Peeps. It's currently 0. Now there's no way to increase this, or decrease it, or change it at all even, but I'm going to make it so that every time this button is pressed, everyone in the server gets 1 Snow Peep. Now I'm going to clean this up a bit. First of all, we don't need these things. They're not being used anywhere. We also don't need this thing down here. That was just to show how loops worked. So I'm gonna copy this for those who still want it though. Now, that, if you just put it into a script, it won't work because high isn't assigned to anything. Or well, it will work, but high will it'll just be nil, which is nothing. These two things would kick it would kick me for the funny. This is just another way of referencing objects. This one references the spawn location. How to get services, this one is VR service, and then that. These are numbers. They're a type of thing you can use in scripts. These are all strings as well. And also, yeah, they're strings, so this is a string. This is also a string. In fact, this is the empty string. There's nothing in between those. This is a string. That stuff in there. And then lastly, this is a string as well. Well, everything is selected in blue is part of the one string. Even though it sort of looks like it ends here with the closing square bracket, 3 equals signs, and then another closing square bracket, that is not the end, because the opening one had 4, not 3. It ends down here where there are 4. See, there's 4 there. And there's 4 there too. All we really need for this is this stuff here. We have some initializing, some variables we'll be using everywhere, making a function that does stuff, and then actually calling that function when we want. And then we have this other script that just sets up the leaderboard. Now, we're actually not done with this script, because I'm going to add a for loop. So, after it gets ready to destroy the item, I'm going to make a for loop. For I play here in game.players.getPlayers. Now, you can use getChildren here. It's not advised. Use getPlayers instead. You can only use getPlayers with this players object, though. It's designed for that. And then, so, for each player that is currently in the game, do this. So you get that player, look for something in them called leader stats. look for something in that folder called snowpeep. Has to match exactly. And then find the property of that thing that is value. And then add 1 to it. So plus equals just means take this and make it equal to what it currently is plus whatever is over here. I think there's also, actually no, if you wanted to subtract, you could do plus equals with a negative number, but I'm just going to do 1 and play here to see if it works. So what this will do is every time the button is pressed, it will spawn a snowpeep, launch it in a random direction, and everyone on the server will get 1 snowpeep leader stat. And then they despawn after however many seconds. And then I said I was going to finish once I added walls, but I'm actually also going to add a badge to show you how to do that. I'm going to make the badge, you get a badge for having 1,000 snow peeps. Alright, so first things first, I'm going to add some walls. Probably a good idea, so they don't just roll off the edge. So I'm going to get a part, put it here. Right, there we go. Now I have the wall, I can just copy and paste it a few times. Don't worry, I make them invisible afterwards. So that's the back wall. And then one last wall, and then I'll have the ceiling. Alright, and then one last thing, which is the ceiling. So now it looks like there's actually nothing happening at all. And then one last thing, I'll make it so that you get a badge at 1000 peeps. So, first I'm gonna quickly design a badge icon. I'm gonna take a picture of it. So let's see. Peak badge design. Now I just make the badge. I'll put the image on it later. I have to save it to Roblox to add the badge, but I'll do that. Alright, once I make this badge, which may take a bit of time, I'll show you how to actually add one. So here I have this. Took me a bit of time, but I found badges. The badge, blah blah blah. $1,000 snow peeps. And now that I have the badge made, I can go here. I can get the ID of the badge somewhere. I think it's here. So now that I have that, although I guess I could find it in here as well. Yeah, that is it. Alright, there we go. Now I have that. Now, to actually give out the badge, I need... I'll have a player script do this. Alright, so first we need... So this will be in the player. I'll actually make it a character script, so that, yeah. So, player equals game.players get character from model. So, let's say there are like 5 people, and I only want this script to affect one of them. I could... If I want it to affect one person, and I happen to have a reference to their character model that is in the world somewhere, the way I get their player that's in this, which is different to the character model in the world, is I use this function get player from character. So I give it, I think it should just be, should be where it is, but if not, I'm gonna do this. This script is gonna go into their character model, so when it searches up to find a model, it will find their player. And then from there, I'll get that player. And then peep count is now I'll just make it so that every 5 minutes it checks if you can get the badge, and then we'll give it to you, because I don't want it to check every single time the number updates, because that is a thing you can do, and I think it'll just be better to have a check once every 5 minutes. Downside, of course, being that you'll have to wait till the next multiple of 5 minutes that you've existed. Or I guess you could die and respawn, and that would also work. Because this goes in the player character, it'll refresh the script whenever you die. And also, something I've not yet said, if statements. You probably already know what they are, but an if statement is, if this thing is true, then do this. Otherwise, if it is not true, do this other thing. You can also chain if statements together using the keyword else if. So rather than just doing if blah blah blah, so if peep count.value is greater than or equal to 1000, then it will award the badge. Now to actually award the badge, you need to use the badge service. And then you do award badge async. Or no, it's just award badge. It's synchronized, so there's no async. And then we just get player.userid. So we give them the badge. And then that's the badge ID. And I'm not going to worry about any of the errors that could come from this, such as they already have the badge is currently off sale, or the badge fails to get the badge information because they're not connected to the internet. I'm not going to worry about any of that, I'm just going to leave it like this. Now, if they don't have 1,000, nothing will happen. So I could have an empty else here, or I could just leave it blank. Just get rid of this entirely. But what if I wanted to check something else? So like, maybe they don't have 1,000 yet, like maybe I add more badges in the future for 500, 250, 10,000, 100,000, a million. Then I would check here with else if, which is basically just starting another if statement. If I could just do this. But I can't have it be exactly the same, because it complains about that. Because, like, think about it, if it already happened, they don't need to check for it again. And then, for example, I could check if they may not have over 10,000, but maybe they have more than 5,000. But this is bad game design, because they might skip over 500 and then not be able to get it when they get 10,000, because it'll get to 10,000, it'll get to 1,000, stop, and they won't get any of the other ones. Which is why, instead of using else if, you could end this if statement with just end, and then start a new if statement, so that all of these things happen. But if it was like tallying up points from a round, it may be better to use else if a bunch of times, based on whatever score they got. Anyway, we don't need that. But one more thing we do need is for it to yield and let other stuff happen. Also, it's important, note that I've put the task.wait after the check. This is so that if you die and then you respawn, this script will run again, and the first thing it does is check if you have 1,000 or more, and then you'll get the badge. Then it will wait 5 minutes. If I put this first, you would have to wait 5 minutes when you died to have a chance of getting the badge, rather than having a chance of getting the badge first, and then having to wait 5 minutes. So, if this works, I should get the badge once I get past 1,000. And I will actually get the badge. You'll get the the thing will appear in the corner, and it'll appear in my inventory if you go to my profile. So, here we go. Wait, I can just do this. There we go. I got the badge. And now, if you go to my profile, it should appear there. I'm gonna go check. So here, if we go here, yep, there it is. Okay, got it. And now, because I have the badge, other people can get the badge, because one of the requirements for obtaining a badge that you're not the creator of the game of is that the creator of the game has the badge in their inventory. So, now other people can get this badge, and yeah. Simple as that. To give out a badge, you literally just get badge service, and then use the award badge function on a player with their user ID with the badge you want to award them. And it's that simple. But you can the award badges that are part of the game, you're awarding them in, so like I couldn't just give myself detonator like this, that just wouldn't work because it's not the right badge. However, you can check for badges in any game. So like there's a badge service has another function called get badge info async, which means that if you give it a badge ID and it gets the information for the badge, like its image, its name, whether it is obtainable, like whether the creator has it disabled or not. And you can also check if a player has a certain badge. So yeah, that's badges. Alright, so this is a fling snow peep with your friends simulator. One last thing I will do before ending is make an icon and image. I'll just take a picture here. Alright, yeah, there we go. Alright, so you should be able to go to my profile and play this. Alright, right, yeah, that's pretty much it. Um, you can fling snow peep with friends. You can play with your friends. You can talk. Um, you can press the button. You can, yeah. Who knows? You might see me there. Yeah, that was coding, and I coded. Yeah, that has been, yeah, coding lecture. So now all we can do is we can play it now. The last few minutes, I'll play for around 20 minutes or so, and then yeah.
Hi.
Hello.
And what are you teaching?
We made.
May I ask you?
I made. I made
Game?
launch Snow Peep with friends. Look at this.
Snow peep.
So many Snow
Snow
Peeps.
peep
Yeah, there's so many of them.
or snow poop with friends, or snow poop alone.
You should join me for real. Do you have premium?
For real, I will join you
I
right now.
need premium payouts. Fun fact.
Admin Roblox, please.
Fun
Admin
fact.
Roblox.
Okay, only if you join. Also,
I
fun
will
fact. I'm
join.
actually getting free Robux from this because there are premium players in my game.
Give me the free Roblox, please. I'm poor. I need Robux to create a group right now. Please, please, man. I beg you.
Join us and make peeps.
I will make peep if you add me in Roblox. I'm joining you.
We need Snow Peeps.
I need. I need you.
Why are you so gnarp gnorp?
I'm so gnarp gnarp, yeah. Can you give me free friend? I wanna make friends in this game. I'm deleting some random person so I can add you. John. John. John, you're so awesome. You're so handsome. Please, can you get admin in this game?
Yes, I can add you. You
I'm
need to
just
add me
kidding.
though.
I don't need any. I don't need. I don't need any from you. I want to add you. That's all that I want. Wait, let me delete someone. Okay, add me. Let's go. Oh yeah, why are you screenshotting that? I just wanna add you. Yes, let's go.
Yippee.
Let's go. Yo, I wanted it so much. Yeah, let's go. I can now leave.
You can also respawn and you get the badge.
Oh, 1,000 snow peeps. Can I get a glove for that? Like,
If
snow
Tencel
peep
added
glove.
a Snow Peep glove that you
Pencil
got for that
smells.
badge, then you could.
Wait, let me change my skin real quick. Hmm. I'm pretty sure you all don't want to see my face, but well, I just want to show you something. Hello guys, it's me, Freedom.
Ulimbole.
Can someone screenshot that right now, please? Need it.
No way. Is that man face mug?
Yes, about it today. Also about Mountain Dew. Yippee. Okay, let's go. Oh,
Eventually, I'm
I'm
gonna
glad
make the
that
sequel to launch Snow Peep
I'm
with
glad
friends.
that I didn't.
Launch. Wait a minute, I could
I
turn
did.
this into an entire game series where it's launch random object with friends.
John, we need to go.
Yes.
What cereal you got, John? What cereal you got? I got cereal number 3.
Hmm?
I'm not sure, but I think my cereal is gonna like be expensive because the original Snoopy will be like 1,000, I think, and the cereal number 3 will be like 5,000. Am I right? Well, the reason
I
I
cannot
joined,
hear you.
I want to wish you all guys happy nice day. Хули ты тут рыгаешь, блядь? I'm sorry. My friend joined. He's handsome, right? Look, John, he's
So
handsome.
handsome.
This guy,
So handsome.
he's nothing. He's chasing me. Oh my god. Well, I wanna wish you all a nice day, guys.
You too.
I hope you're doing okay. You all yeah. Goodbye, guys. I wish you the best.
Maybe. I hope Freedom is doing well. Womp. This game is so good, we need to tell the Snow Peep cult about it immediately. Alright, so I have a small list of things that I will add in the next update. I'm going to add
No way.
2 new buttons, and also more badges. So first of all, I'm going to add, it's currently a 1000 badge for Snow Peeps, but I'm going to add 2 more buttons for Rob and Bob plush, and I'm also going to give them their own leaderboard stat. And along with that, their own badges. There's going to be a badge for 1000 of each thing, 10,000 of each thing, and a million or 100,000. Because like a million is a bit much. Maybe I might add 4. Problem is, I cannot add 10 bajillion badges. Once I add 5, it costs 100 Robux per badge. So I may add donations so you can
Oh my
support the
god,
game.
it is so fast.
Earlier when I said I would go until sometime, I think it was like 7:30. That was 10 minutes ago, so I'm actually just gonna wait until this person gets 100,000 peeps. While they're busy getting to 100,000, I'm gonna continue making. I'm gonna add a couple more badges, and they won't be obtainable until I restart the servers, but I'll add them. And then I'll also add the meet the owner badge. Cause yeah, Getting so close to 100,000. I'm going to steal his head. Alright, I'm gonna actually write the list for what updates are gonna be added, what things I need. And then I'm gonna add those things in my free time. Currently on my update list I have we've been here for quite a while. I think around maybe half an hour from now I'll stop. I'll end the stage lecture and we will yeah, that'll be it. it's almost 9 o'clock, so I'm gonna finish up the lecture soon. We had fun, played around. I'm gonna add some more badges and things and a leaderboard, and also the ability to cut your own head off and live, and then hold your head. Yeah. So, I'm gonna end the lecture. You can still play the game, of course, obviously. But, yeah. That has been coding and stuff. Alright, so there's gonna be another lecture at some point in the future. It's gonna be on Sunday, but not next Sunday, maybe the one after. If not then, maybe the one after that. I honestly have no idea when I'm gonna host another one of these. So, yeah. Have a great day, week, month, however long it takes for the next one, and I will see you then.